Hello, it's Graham Johnson with Ludovic Altine, Michel Sanner, David Goodsill, and Art Olson. Today I'm going to describe some of the capabilities available in the graphic user interface of our embedded Python molecular viewer. ePMV merges the capabilities of molecular modeling software and other scientific algorithms with professional animation software and provides access to the powerful capabilities that each system can offer. We do this by embedding our lab's own Python molecular viewer directly inside of a hosting 3D software application, in this case Cinema 4D, but it's also available in Blender and Maya. Today I'm going to step through these 5 panels in the current version of our GUI to show you what each one does and some of the basic functionality available in each. And I'm going to show you how to generate each of these 9 representations. Here I've loaded a small snippet of a protein molecule, and I'm showing several different styles of traditional molecular graphics representations for that molecule. But I'll do that in context, and we'll start with a fresh file. And in our data access panel here, I could either browse to a file from our hard drive, or I can load one directly from the web. In this case, I'm going to load Crambin by fetching from the protein database as opposed to one of these other optional databases. And straight away, if I zoom in, I see that a point cloud has been generated where there's one point for every atom in the protein database file for every XYZ position available. Next, I can generate a line representation by skipping the selection panel for now and moving down to our molecular representation panel, choosing one of the available presets, which is lines. Now we've got a line cylinder for every one of the bonds in our system. And I can see up here that that's generated in this objects palette a hierarchical graphic representation of that line object. I can highlight that and turn it off from within this system as well as from within the ePMV panel. Next, we can generate a ball and stick representation, and we have options in here to scale the size of the cylinders and spheres that represent the atoms and bonds, or to change the ratio of the cylinders to the spheres. If we set them at 1 and change these to 1, for example, we can get a standard stick representation. I can turn on space filling representation, and here I've got similar control of the scaling of the van der Waals radius, the default van der Waals radius that I can modify to any radius of my choosing. And I've got color selection options available down here. So instead of coloring each atom by its standard atom type color, I can choose to color the entire amino acid chain from its N terminus to its C terminus using ROY-G-BIV. Or I can color per residue, where each amino acid in the chain gets a distinct color. And I can see that because I had both sticks and atoms turned on when I changed the coloring scheme, that it's applied to the space filling model as well as to the underlying stick model. We can generate molecular surfaces, and this is unique that typically if you import a VRML file exported from a molecular graphics viewer into a hosting software application, these software packages aren't designed to view the vertex coloring scheme that you see in your molecular graphics viewer, and we've set up a workaround for that that allows you to get these representations, color representations, during your render time exactly as you would expect from your molecular graphics viewer. And the same applies for coarse molecular surfaces. We can adjust the ISO surface value and the resolution on the fly. And we can color them using the same coloring schemes that are available. I'm going to make a selection right now to restrict the next two pieces of geometry I build. First, build a spline that connects a three-dimensional line to each one of the C-alpha carbons because I selected to use the C-alpha carbons. By default, this would have built a connecting line between each one of the atoms in the amino acid backbone. But I just wanted to connect the C-alpha carbons, and now I can use some of the host features, for example, to build a worm representation by extruding or sweeping a circle along that spline. And if I want softer edges, I can use the host features to interpolate the spline instead of linearly to round off the corners of the C-alpha carbons along that spline. And another advantage of the host is I can, in a relatively intuitive fashion, after spending a little bit of time studying the tutorials available for these packages, for example, I can colorize any item in the system. Using that same C-alpha selection, we can also generate an inverse kinematics armature, and this can be used to animate any geometry that it's connected to, and I'll show you a demonstration of that in a second. And if I turn off C-alpha, I can generate a standard ribbon representation. Again, that's custom colorizable, or we can apply any coloring scheme, in this case secondary structure. And I can again use the features of the host to generate my own materials in a relatively intuitive fashion and apply them. In this case, I've made a blue color material to replace the pink on one of these alpha helices. That shows you all the basic features of the molecular representations panel. I showed you a little bit of the selections palette as well as the browsing palette. I'll show you some of the data features in the data panel and then some of the scripting next. First, I just want to show you, if I apply that armature, and I'll have a separate tutorial for this, to that inverse kinematic system, I can use that to animate conformational changes to any underlying structure. And this may be scientifically invalid, but I can freeze that point there, for example, move the timeline a few frames ahead, move this point back to where it was. And that sets up an animation in between those 2 points. We can import data in a variety of formats to generate, in this case I've got an electron density map downloaded from the crystallography server, crystallographic density server, that's overlaid, that allows us to generate typical figures for publication. And I'll have again a separate tutorial showing you the details of how to set something like this up. And we can generate other types of typical structure biology renderings using the host software and some of the features available in the host that are relatively intuitive to set up and adjust, that we will describe in more detail in other tutorials, but just want to give you a brief survey of some of the functions of this panel